even versus odd functions comes from or within chapter 1 or section 1.3, and we're going to look at how can we tell if a function is even or odd. Okay, so if we know a function is even, what does it tell us, or what do we know about it? Thinking back to the characteristics of a function that we talked about on the first day in section 1.1. So what does an even function have, or what is a characteristic of an even function? Okay. So an even function will have a line of symmetry, okay, which means that function, if we're kind of looking at the graph, it's either going to go from quadrant 2 to quadrant 1, or it's going to go from quadrant 3 to quadrant 4. Okay, so those are they have to have that. So how we can describe an even function, or how we can recognize an even function, it's going to be an even degree function. Okay, so our leading coefficient is going to have an even degree exponent, where the exponent in each term is even. So we're going to extend the condition. So we started off with saying an even degree, it has an even exponent, but for a function to be even, every term has to have an even exponent. Okay, and what we're looking at is, if we're able to put a little sketch to that, it would look like our quadratic. A quadratic is one example, and what we'll say is this point f of x is going to have the same y value as the point f of negative x. And that's for all x in the domain. Okay. We could get an even function that looks a little bit different. It could look like that, but we're still going to get the same condition where f of x has the same y value of f of negative x. Okay, and when we're looking for an even function, will be symmetric about our y-axis. Yeah. Well, let's say when you plug in, say we have an x value of, say, 5. When you plug in negative 5, you have to get the same y value. Okay, so whenever you plug in the negative of the x, you have to get the same y. And we're going to do a couple of examples to go through that. Okay, so if we define an even function as a polynomial where every term has an even exponent, kind of similarly, we're looking for an odd function, an odd degree polynomial function. Okay, an odd degree polynomial function where the exponent in each term is odd. Okay, so an even function, each exponent has to be even. For an odd function, each exponent has to be odd. Okay. And we're not going to have a line of symmetry here. We're going to have a rotational point of symmetry. And we're going to have a rotational point of symmetry about the origin, 0, 0. Okay, so we started talking about these kind of briefly the other day, where if we have, say, our cubic function, just x cubed, then we're going to have a rotational point of symmetry at the origin, where if we took this half of the graph and spun it up here, it would lie on top of one another. Okay. We can get a similar type graph for a more kind of advanced cubic function that's going to look like this. We can get a point of origin, or sorry, a rotational point of symmetry right here, and we could spin that around. The condition for an odd degree function, or an odd function, we're looking at satisfying the condition that f of negative x is the same as negative f of x. What that's going to mean is that, say, f of negative x and the point over here of negative f of x, those y values are the same. So to summarize, we have these two conditions. We have a condition for a function to be even, and we also have a condition for it to be odd. What we'll do now is go over a couple of examples how we can algebraically we're looking to algebraically prove okay, so we're going to go through 3 examples how to algebraically prove if a function is even or odd. And the first one we're going to go through is f of x equals negative 2x squared plus 6. Okay, so just give me a guess as to what you think that function is going to be. Is it going to be odd or even? Okay, so it looks even. Okay, so it looks even. So we have to show, or we have to prove, that f of x equals f of negative x. So if you're asked to algebraically show, you just can't recite a definition and say, it falls under the definition. We're given these conditions that f of x equals f of negative x. So that means we have to show that the function that we're talking about actually satisfies these conditions. So to prove this, we have to sub in or evaluate f of negative x. So we're going to be looking at our function, and we're going to be subbing in negative x. So to do that, wherever we see an x, we put a negative x. And negative x squared is what? We're going to evaluate negative x squared. What's that going to work out to? It's going to work out to x squared. So we're going to get 2x squared plus 6 for f of negative x. So now we look at the function f of x, and we look at the function f of negative x. Looking at those two, they're equal. So we know we have an even function. And this function will be symmetrical about the y-axis. Our second example, we're going to classify the function f of x, and that function is negative 3x cubed plus 8x. Okay. What do we think that function is going to be? Do we think the function is going to be even or odd? Odd. Okay. So looks odd. What's the condition for it being an odd function? Okay. So it has to satisfy this. We're looking at it, we can read the definition. It looks like it's going to be a negative function, but we have to algebraically show it, which means we have to work it out. So we have to evaluate f of negative x, which is the exact same procedure, exact same steps we just did. So we're going to look at that, and we're going to say f of negative x will be negative 3 times negative x cubed plus 8 times negative x. What's negative x cubed? Negative x cubed. Okay, so it'll be negative 3 times negative x cubed. And then we have 8 times negative x is going to be minus 8. Multiply this one in. So f of negative x is going to be 3x cubed, oh, forgot my x, minus 8x. Now, to evaluate negative f of x, all I do is I take the negative of my function. So I'm going to start with a negative. My function is negative 3x cubed plus 8x. I'm going to multiply a negative through, and negative f of x is 3x cubed minus 8x. Then we go back, look at our two functions, and recognize that f of negative x does equal negative f of x. It satisfies the condition that we do have an odd function. Okay, so the third example we're going to do, we're going to classify the function 4x cubed minus 6x squared plus 7x plus 2. You could probably guess that this one's going to be neither, because we've done an example for odd and an example for even, but we have to actually show that. So looking at this, you got to start somewhere. I would kind of look at this, and where you'll get confused is you'll look at it and say, oh, the first term's 4x cubed. That's going to be an odd function. Okay? This is a process that will go through your heads. And for it to be an odd function, we know that, well, we got to try and show that that is true. Okay? So we start the whole process again, and we'll say, well, f of negative x okay, and you'll work through that, and we'll get negative 4x cubed minus 6x squared minus 7x plus 2. And if we look to evaluate negative f of x, so we would go to evaluate negative f of x. We're just going to switch the signs on all those, and we get negative 4x squared plus, or 4x cubed plus 6x squared minus 7x minus 2. And we compare what we get for negative f of x and f of negative x, and we find that those are not the same. Okay, and those tell us that it's not odd. Okay, so you go through and you thought it was an odd function. We tried to prove that it was an odd function, and it failed that test. So now we know it's not odd. So then what will go through your mind is, well, maybe the odds in an even kind of cancel out, and it's back to being an even function. So then we're going to try and test to see, well, maybe it is an even function and we're not sure. If it's an even function, then we know that f of x is the same as f of negative x. So we go and look up and see what we have. We know f of negative x is negative 4x cubed minus 6x squared minus 7x plus 2. We know our original function is 4x cubed minus 6x squared plus 7x plus 2. We compare those two. They're not the same either. So now we know it's not even. So we've proven it's not odd. We've proven it's not even. So therefore, this function is neither. So we can say f of x is neither odd or even. So if it's odd, it's not odd and it's not even, what does that mean in terms of the graph? Does that tell us? So this function has no symmetry. There's no point of symmetry, no line of symmetry.